Good morning to everyone. This is Maulika, Assistant Professor, Department of Physics from St. Josephs College of Arts and Science for Women, Hosur. In this video, I am going to explain about moving coil ballistic galvanometer. This moving coil ballistic galvanometer instrument is used to measure the electric charge. The principle of this galvanometer is when a current is passed through a coil suspended freely in a magnetic field, it experiences a force in a direction given by Fleming's left hand rule. The construction of this galvanometer, it consists of a rectangle coil of a thin copper wire wound on a non-metallic frame of ivory, and it is suspended by means of a phosphor bronze wire between the folds of a powerful horseshoe magnet. A small circular mirror is attached to the suspension wire. Lower end of the coil is connected to a hairspring. The upper end of the suspension wire and the lower end of the spring are connected to terminals T1 and T2. A cylindrical soft iron core, that is C, is placed symmetrically inside the coil between the magnetic folds, which are also made cylindrical in shape. This iron core concentrates the magnetic field and helps in producing radial field. The ballistic galvanometer is used to measure the electric charge, and the charge has to pass through the coil as quickly as possible and before the coil starts moving. The coil thus gets an impulse and throw is registered. To achieve this result, a coil of high moment of inertia is used so that the period of oscillation of the coil is fairly large. The oscillation of the coil are practically undamped. Now we will discuss about the theory part. Consider a rectangular coil of n turns placed in a uniform magnetic field of magnetic induction. Let in this figure L be the length of the coil and B is the breadth of the coil. We know that the area of the coil is length into breadth. So A is equal to L into B. When a current passes through the coil, the torque on a coil is produced. So the torque value is N number of turns in the coil IBA. If the current passes for a short interval dt, the angular force produced in the coil, which is given by NIBA dt. If the current passes for t seconds, the total angular impulse given to the coil is, we are going to integrate the short time period, so we can get the total time. So we can get the value for the total time, that is NBAQ. Here Q is the total charge passing through the galvanometer of the coil, and let I be the moment of inertia of the coil about the axis of the suspension and omega its angular velocity. Then the change in angular momentum of the coil is given by I omega. And the second term is the kinetic energy. That means the second assumption is the kinetic energy of the moving system of I omega square is used in twisting the suspension wire through an angle theta. Let C be the restoring torque per unit twist of the suspension wire. Then the work done in a twisting the suspension wire by an angle theta is of C theta square. Always the kinetic energy of a moving system and the work done in twisting the suspension wire is always same. So 1 by 2 will get cancelled. So finally we get I omega square is equal to C theta square. Then the third point is to find the period of oscillation of the coil. The formula of that T is equal to 2 pi square root of I by C. So we square the period of oscillation, then we get T square is equal to 4 pi square I upon C. So the multiplying equation 6 and 7 we get I omega is equal to c t theta by 2 pi. This I omega value we got now. So the equation 5 and 8 now we equating, then we get NBAQ is equal to C theta by 2 pi. From this equation we can get the charge value, that means Q, that is Q is equal to T by 2 pi C upon NBA theta. Here T is the period of oscillation, pi we know the value 3.14, C is the torque, and N is the number of turns in the coil, B is the breadth of the coil, and A is area of the coil, theta is an angle. This gives the relation between the charge flowing and the ballistic throw, theta of the galvanometer. So Q is directly proportional to theta. Here K is the ballistic reduction factor. That factor is equal to T upon 2 pi C, that means torque upon NBA. So finally the charge value is ballistic reduction factor and theta value. But we have to do damping correction to get an exact charge value. And this is the experimental setup for moving coil ballistic galvanometer. The conditions for a moving coil galvanometer to be ballistic, that is the moment of inertia of a moving should be large, and the suspension fiber should be very fine, and air resistance should be small, and finally the damping should be small, that is the coil should be wound on a non-conducting frame. So this is about the moving coil galvanometer. It is used to find the measure the electric charge, and it is very sensitive. Thank you.